Hey everyone and welcome. Today we're going to dig into one of the most powerful ideas in all of economics, market equilibrium. We're going to go beyond just talking about it and actually look at the simple, elegant math that shows us exactly how markets find their perfect price. Let's get into it.
Have you ever really thought about it? Why does a cup of coffee cost what it does? Or a new phone? It's not random. There's this incredibly powerful, predictable process going on behind the scenes, something people call the invisible hand of the market. And today we're going to show you exactly how that hand works using just a little bit of algebra.
So here's our game plan. We'll kick things off with a big picture definition. Then we'll get our hands dirty with the math. After that, we'll solve for equilibrium step by step, run through a real number example to make it stick, and finally, look at what happens when things go a little off balance.
All right, first things first, what exactly is this equilibrium we're talking about? Well, think of it as the market's happy place. It's that stable resting point where everything is perfectly in balance. Now, the key phrase here is willing and able. It's not just about what people want, it's about what they can actually afford to buy. And it's not just about what sellers could make, it's about what they're actually willing to sell at a certain price. When those two forces meet perfectly, the price just settles. There's no pressure for it to go up or down. It's stable. So look, these four statements on the screen, they're really just four different ways of saying the exact same thing. If the amount people want to buy equals the amount people want to sell, that's our core equation, QD equals QS, then it logically follows that there can't be any empty shelves and there can't be any overflowing warehouses. The market clears perfectly and the price just locks in. Okay, concept down. Now let's translate this into the language that economists love to speak. Algebra. This is how we actually model the behavior of buyers and sellers to make really precise predictions. On the left, you've got the demand function. That's us, the buyers. And on the right, the supply function, which represents the sellers. Now, the first thing you probably notice is the huge difference, that minus sign for demand and the plus sign for supply. But don't overlook A and C. A is kind of like the maximum possible demand if the product were totally free. And C represents the baseline amount sellers would offer, maybe based on their costs. These constants are where real-world conditions get plugged into our model.
This one is super intuitive, right? It's just the law of demand. When the price of something goes up, we, as a group, tend to buy less of it. Simple as that. In our equation, that relationship is captured perfectly by that negative slope, our friend negative b.
Now, let's flip the script and think like a seller for a second. If you could suddenly get a much higher price for what you're selling, what would you do? You'd crank up production, right? You have a huge incentive to make and sell more. That's the law of supply. And it's why that slope plus D is positive.
All right, we have our two main characters, the demand function for buyers and the supply function for sellers. So how do we find that one single price where they both agree? Let's walk through the algebra, step by step. It's easier than it looks. This is basically our four-step playbook. It's a simple recipe that works every single time. We start by stating the fundamental condition. Demand must equal supply. And then we just use some basic algebra to find our two magic numbers, the equilibrium price and the equilibrium quantity. And this is the engine of the whole operation. We take our two equations, smash them together, and when we rearrange everything to get P by itself, we end up with this beautiful, universal formula. That P with the little asterisk, economists call it P star. That is the one and only equilibrium price for that market.
Okay, theory is great, but let's make this real. We're going to swap out those letters for some actual numbers and find the equilibrium for a market right here, right now. So here are our equations for this market. On the demand side, we have 100 minus 2p, and for supply, we've got 20 plus 3p. You can see it right there, that negative slope for demand and the positive slope for supply, just like we talked about.
And here we go. Step one. We start with that golden rule of equilibrium. The quantity demanded has to equal the quantity supplied. So we just set our two equations equal to each other. That's the starting line. Now we just do a little tidying up with some algebra. We'll add 2p to both sides to get the p's together, and we'll subtract 20 from both sides to get the numbers together. This boils it all down to a much simpler equation to solve. 80 equals 5p.
And the big reveal? We just divide 80 by 5, and we get our equilibrium price. P star is 16. This is it. The one price where this market will find its natural balance.
But wait, we're not done. We have the price, but how many units actually get bought and sold? So we take our price of 16 and plug it back into one of the original equations. And here's the cool part.
It doesn't matter which one you choose, the answer will be the exact same, because that's what being in equilibrium means. We'll just use the demand function here. So let's see. 2 times 16 is 32, and 100 minus 32 gives us our equilibrium quantity, or Q star, and that number is 68. So at a price of 16, exactly 68 units will be demanded and exactly 68 units will be supplied. The market is perfectly cleared. So knowing the balance point is huge, but it's almost more interesting to see what happens when the price is not at that magic number. This is where we can actually see the market forces at work, always trying to push the price back towards equilibrium. And it all boils down to this. If the price is too low, everybody wants to buy the item, but sellers aren't making enough of it. That creates a shortage. On the flip side, if the price is too high, sellers have tons of stuff sitting on shelves, but not enough people are buying. That's a surplus. Let's go back to our example. We know the right price is 16, but what happens if the price was artificially held down at 10? Well, at that amazing price, buyers would want 80 units, but sellers would only be willing to supply 50. See the mismatch? That leaves a gap, a shortage of 30 units, and that shortage creates pressure that pushes the price back up towards 16.
And that brings us to our final wrap-up. You can think of this table as your ultimate cheat sheet for market equilibrium. It's got the basic structure for demand and supply, the absolute core condition for balance, and the exact formulas you need to solve for the price and quantity that clear the market.
So we'll leave you with a little food for thought. Remember how we said A and C represent all those outside factors? Like A reflects how popular a product is, and C reflects the cost of production? So what happens to our equilibrium of 16 and 68 if a viral TikTok video makes the product super trendy, causing A to skyrocket, or a new technology makes it way cheaper to produce, changing C? The math we've gone over today is the exact tool you would use to find that new balance point.